This $25 clay pipe cools your house 30 degrees Fahrenheit without electricity. Why is nobody using it? A strange truth hides beneath your feet. While modern homes depend on expensive air conditioners, fragile power grids, and rising energy bills, the ground below remains cool and steady every day of the year. That simple fact helped ancient builders survive brutal summers long before electricity existed. Today, the same idea can be recreated with little more than clay pipes, a shovel, and some patience. For preppers, homesteaders, and anyone thinking about long-term resilience, this forgotten cooling method feels almost too good to be real. Yet the science behind it is surprisingly simple, and the results can be remarkable. Modern air conditioning is an engineering achievement, but it comes with a weakness. It only works when everything else works. Electricity must flow. Equipment must function. Replacement parts must be available. During major heat waves, demand surges as millions of cooling systems switch on at once. Power networks become strained. Blackouts become more likely. When that happens, many homes rapidly become uncomfortable and sometimes dangerous. The same insulation that keeps cooled air inside can also trap unwanted heat when mechanical cooling stops. Ancient builders approached the problem differently. Instead of fighting the heat with machines, they worked with natural forces. They understood that the earth itself acts as a giant temperature regulator. Just a few feet below the surface, temperatures remain relatively stable throughout the year. Even when the air above is scorching hot, deeper soil often stays dramatically cooler. That stable underground environment becomes the foundation of an earth tube cooling system. The concept is straightforward. Hot outdoor air enters a buried pipe. As the air travels underground, heat transfers through the pipe walls into the surrounding soil. By the time the air reaches the home, it can be significantly cooler than when it entered. The process requires no compressor, no refrigerants, and very little energy. In some setups, airflow happens naturally through pressure differences. In others, a small solar-powered fan helps move air through the system. One detail makes this design especially interesting. Many modern builders automatically reach for plastic pipe. While plastic is durable and easy to find, it is not ideal for transferring heat. Clay, especially unglazed terracotta, behaves differently. Because it is made from fired earth, it exchanges heat more effectively with the surrounding ground. In some conditions, it can also interact with natural soil moisture, creating a mild evaporative cooling effect that further lowers air temperatures. That combination of geothermal cooling and evaporation is what gives the system its reputation. Under favorable conditions, incoming air may drop by 20 or even 30 degrees Fahrenheit before entering the living space. The exact performance depends on soil conditions, climate, pipe length, and installation quality, but the potential is substantial. Even a moderate reduction can transform an uncomfortable room into a livable shelter during extreme heat. Building an earth tube system is labor-intensive but conceptually simple. The first requirement is depth. Pipes are typically buried 4 to 6 feet underground, where temperatures remain relatively stable. The second requirement is length. Air needs enough travel distance to exchange heat with the earth. Short pipes provide limited cooling. Longer runs, often between 50 and 70 feet, give the system a much better opportunity to remove heat from the incoming air. The intake opening must be protected with strong screening. Cool underground pipes attract insects and small animals seeking shelter. A properly fitted metal mesh barrier helps prevent unwanted visitors from turning the system into an access tunnel. Good filtration also improves air quality and reduces maintenance requirements over time. Perhaps the most important design feature is drainage. Warm air contains moisture. When that air cools inside the buried pipe, condensation forms. Without a way to remove that water, the system can develop standing moisture. Stagnant water encourages mold, mildew, and bacterial growth. For that reason, the pipe should be installed with a gentle downward slope away from the home. Condensation can then flow naturally toward a drainage area instead of collecting inside the tube. Climate also matters. Earth tube systems perform best in hot, relatively dry regions where evaporation can contribute to cooling and moisture levels remain manageable. In extremely humid environments, condensation becomes a much larger challenge. Successful installations in those areas require careful planning, excellent drainage, and ongoing monitoring. The technology still works, but it demands more attention. For preparedness-minded families, the appeal goes far beyond comfort. An earth tube system represents independence. Once installed, The cooling effect comes from natural temperature differences rather than continuous energy consumption. There are no refrigerant leaks to worry about, no large motors running day and night, and no dependence on utility companies during every heat emergency. That does not mean the system replaces modern air conditioning in every situation. A buried clay pipe will not create the icy blast produced by a large electric unit. It is better understood as a powerful pre-cooling system. Instead of turning blazing hot air into refrigerator cold air, it turns oppressive heat into something far more manageable. That distinction matters because realistic expectations lead to better results. The larger lesson may be even more valuable than the cooling itself. Many traditional technologies disappeared not because they stopped working, but because newer systems seemed more convenient. Over time, society forgot practical methods that relied on natural forces instead of constant energy consumption. Earth tube cooling is one example of that forgotten knowledge returning to the spotlight. As temperatures rise and energy costs continue climbing, more people are searching for resilient solutions. A network of buried clay pipes may never replace every modern cooling system, but it offers something increasingly rare. It works with nature instead of against it. Beneath every backyard sits an enormous reservoir of stable temperature waiting to be used. The question is not whether the physics works. The question is why more people are not taking advantage of it.